Are you Charnel Reynolds?
Who's asking?
We are. I'm Susan, and this is my partner, Diana. We're the tutors. You are wanting tutors, right?
Oh, for chemistry.
Yeah, can you tell us about the project? It says here a little something.
Well, we have to look up all this information about the periodic table and present it to our class. It's lame. I don't even know who Antoine
Lavoisier.
Yeah, who is he? And what are with the trends of the periodic table and all that stuff?
I think we can help with that.
Wait, we what?
Whoa, dude, what's this? I don't know, but let's work with it. Great. Antoine Laurent Lavoisier impacted chemistry. He made a theory about the reactivity of oxygen. He's known for discovering the role oxygen plays in combustion. Next is John Newlands, made the law of octaves in 1864 and also arranged the periodic table by relative atomic mass. But if it wasn't for the next two, he couldn't do the task. Julius Luther Meyer was a German chemist. He was very instrumental in developing the periodic table of chemical elements, which he and Mendeleev helped to invent. Dmitri Mendeleev made periodic law, and he put the elements into rows and columns. Rows are based off atomic mass, columns by chemical and physical properties. The man is back to so great he can even rival Socrates. Lastly is Henry Moseley, an English physicist. He contributed Moseley's laws, which simply is the fact that similar properties recur periodically, obviously increasing by atomic numbers. You see, that's all it is. Talking about the periodic table. Learn it if you're able. Got a lot of labels. We talking about the way that this all works. Listen to the words, please listen, just listen. We talking about the periodic table. Learn it if you're able. Got a lot of labels. We talking about the way that this all works. Listen to the words, please listen, just listen. The table has 18 groups, or you could say columns, with only 7 periods, also called rows. And to know the orbital, just look at the numbers. It tells you what will give and take, so don't be stumped any longer. But why would they do that? I'm glad to answer your question. See, every element is trying to get to 8, not to 7. They wanna be a noble gas and wanna match their valence, so they give up or take electrons in order to get with. Next is trend. They're super easy, so easy. The trends are also super easy that you're gonna say them with me. Atomic and ionic radii decrease from right to left, but when they travel down groups, they increase themselves. Ionization and electronegativity, they both increase from right to left, and down the groups they decrease. I know that was a big mouthful to say, so go ahead and do the chorus and we'll take your breath away. We talking about the periodic table. Learn it if you're able. Got a lot of labels. We talking about the way that this all works. Listen to the words, please listen, just listen. We talking about the periodic table. Learn it if you're able. Got a lot of labels. We talking about the way that this all works. Listen to the words, please listen, just listen.
SPDF represent sharp, principal, diffuse, and fundamental, which correlate with the visual impressions that each structure leaves. To find where they are, we'll need to look at the columns and elements. In the S block, there is hydrogen, which, unlike the alkali metals, may not always lose its 1-valent electron to make a +1 ion. Then, there are the alkali metals that are very reactive and have 1-valent electron that they want to lose. Lastly, there are the alkali earth metals, which, under certain conditions, the alkali earth metals aren't very reactive. They have and are willing to give up 2-valent electrons. Now, in the P block, there is the boron group. All the elements in this group, aside from the metalloid boron, are metals and form a positive ion by giving 3 electrons. The carbon group has 4 electrons in their valence, and, of this group, only carbon and silicon can form a covalent bond as nonmetals. The nitrogen group can form covalent compounds and usually have a +3 or +5 charge, and except for nitrogen, the elements are solid at room temperature. Then there are the halogens. These all form acid when combined with hydrogen, and they are all pretty toxic. They have 7 valence electrons. Lastly, there are the noble gases, which have a full outer shell of electrons, thus making them very stable. In the D block are the transitional metals. These elements may have more than one oxidation state, otherwise known as charge. Because they're metals, they conduct electricity. Finally, in the F block are the intertransitional metals, which are broken into two groups. The lanthanide group are often rare earth metals and can often be found in ores. Group are mostly man-made, except for uranium and plutonium, which are used in nuclear bombs.
Did that make any sense?
Well, yeah, like, thanks, guys.
Well, listen, anytime you need help with another lesson, give us a call.
Okay,
Bye.
bye.
What was that all about? I don't even know. Did we just sing and rap? Oh, I need a drink. Those bozos. I'm just gonna wait for this. I got like 12 days to turn it in, so yeah. If I wait 12 days and you divide by 300, that's like 25 points a day. I got time. I got time.
We talking about the periodic table. Learn it if you're able. Got a lot of labels. We talking about the way that this all works. Listen to the words, please listen, just listen. We talking about the periodic table. Learn it if you're able. Got a lot of labels. We talking about the way that this all works. Listen to the words, please listen, just listen.